Hey there, everybody. Dr. T here from the Mad Science Lab, and I'm here with some more experiments to show you guys to talk a little bit about motion and movement. Now, we've discussed a little bit of this if you've seen some of our other videos, but not in a lot of detail. We were mostly talking about other things. But I want to talk a little bit more about what we call the laws of motion. Now, these were discovered by a scientist many years ago. His name was Sir Isaac Newton. Not many years, I mean many years ago. And in science, when we call something a law, it's not like a law in real life where you would get in trouble if you break the law. In science, you can't break the law. It's not possible. So when we call something a law in science, that means it describes how things have to act, whether they want to or not. And so the laws of motion tell us how things move, whether they want to or not. So there are 3 laws of motion that we discovered, or he discovered. First law is that an object that is sitting still will keep sitting still until somebody moves it, or until there's a force to move it. And an object that is moving will keep on moving until there is a force to stop it. So, as an example, I set my egg right here on top of this funnel, just like that. Well, the egg doesn't move. Nobody's touching it. Nobody's touching anything, right? Nothing moves. Pretty simple. And you guys probably already knew that law, even if you didn't know it was called a law of motion. All right. The other part of that is something will keep on moving until it is stopped by a force. Now, this one's a little trickier, right? Because you're probably thinking if you ride a bike or something like that, that your bike will slow down on its own if you just stop pedaling. And that's because of a force called friction. But there is a force. And friction is the force of things rubbing against each other. So why don't you guys go ahead and take your hands right here and rub them together like that. Very good. So that force that is making it hard to do that, and that's kind of heating up your hands, that is friction. So that is the force that stops things from moving. But let me show you some examples of Newton's first law in action. So you might have seen this trick done by magicians before, right? Now, I'm not quite as talented as some of those magicians, but I can do something pretty close to it, where they'll take the tablecloth and pull it off the table, and everything stays in place. Now, again, I don't have my full table set up here, but I do have a nice plate and a bowl and a cup right there. And I could show you guys how when I pull this tablecloth right here, like that, I can pull the tablecloth out and all of my items stay right on the table. They don't come with it. And that's because, according to Newton's first law, there was no force acting on those objects, right? I didn't pull those objects. I didn't move them at all. All I did was move the tablecloth. Now, you may have noticed that they moved a little bit, and that is again because of that friction, right? The tablecloth rubbing against the plate and the bowl and the cup made them move a tiny bit, but since I pulled it fast enough, it didn't create very much friction, and so they mostly stayed in place. And of course, we can look at the example again right here with the orange egg. Right now, I'm going to flick this funnel right here that is sitting on top of this cup, and that has the egg on top of it. When I do that, here we go. You'll see that the egg mostly goes straight down. That's because all I did was flick the funnel. I didn't flick the egg. There was no force acting on the egg. All right, so the egg would stay still. Of course, it did go down, so that's not quite still, but that's because the force of gravity was then acting on it, right? And no force was making it go that way. That was just the funnel. Now, Newton's second law of motion is kind of tied into that. And it basically just says bigger things need more force to start or stop than smaller things. So imagine that you had an elephant and a mouse charging at you at the same time. Well, if you put your hand out to stop them, you could probably stop the mouse. You're probably not going to stop the elephant, right? And that's basically what Newton's second law of motion tells us. So that also states that if I put a little bit of weight into this egg right here, it should stay even more still and move even less than it did the first time. And you'll see it goes almost directly down then. That's because the friction, the little bit of friction that did act on it, wasn't having much effect because it was much heavier now. And then finally, we have Newton's third law, which basically says that for every action, there's an equal and opposite reaction. Or, whenever there's a push, there is a push back. For example, I have a little fan car right here. You'll see my fan blades. When they start spinning, they start creating air that pushes that way. The air that's being pushed then pushes back the other way and makes the fan car move. There we go. And so you can see, I'll put it here so you can see it better. And our car starts moving just like that. All right, guys. Well, thank you so much for joining me today in the Mad Science Lab. If you're interested in learning more, you can check us out at dc.madscience.org. And I can't wait to see you guys next time.